welcome you to a class in mathematics, and we will be discussing indices and logarithms. Now, indices and logarithms, these are the parts of mathematics that we are going to firstly take indices. And in indices, we have the laws of indices. And the law of indices, the first law of indices states that a raised to the power of m multiplied by a raised to the power of n is a raised to the power of m plus n. What this law is saying is that if you have a base that they are the same, now the power, you are going to add it. If you are multiplying a raised to the power of m, if you are multiplying by a raised to the power of n, the base are the same. The law says that you will add the power. Take for example, 2 raised to the power of 5 multiplied by 2 raised to the power of 2. What the law says now, it will be what? 2 raised to the power of 5 plus 2, which is 2 raised to the power of what? 7. That's what the law says. Once the base, they are the same. Take for example, 3 raised to the power of 2 multiplied by 3 raised to the power of 3. What will it now be? It will now be 3 raised to the power of 2 plus 3, which is 3 raised to the power of what? 5. This is the first law of indices. When the base is the same, the power will be added. And the second law of indices, because we are still treating indices, it says that a raised to the power of m divided by a raised to the power of n. The law now says that if you are dividing, it will be a raised to the power of m minus n. When you are multiplying, you add. When you are not dividing, what you do is you subtract. Take for example, 3 raised to the power of 5 divided by 3 raised to the power of 3. What does that mean? It will be 3 raised to the power of 5 minus 3, which is 3 raised to the power of what? 2. This is the second law of indices. That when you are dividing, provided the base is the same. The law number 3 is that a raised to the power of m raised to the power of n. There are power into power. It says that the law is that a raised to the power of m multiplied by n, which is a raised to the power of mn. When the power into another power is going to be multiplication. There is an example is if you have 2 raised to the power of 3 raised to the power of 2. It will be 2 raised to the power of 3 times 2, which is 2 raised to the power of what? 6. This is the third law of indices. Then we have the fourth law. The fourth law of indices is if you have a raised to the power of 1 over n, the power is in fraction. A raised to the power of 1 over n. The law says that it will be the n root of what? Of a. A raised to the power of 1 over n is the n root of a. All this is saying is that if you have, for example, 4 raised to the power of half, it will be the square root of 4. You know when you are putting the square root of 4, you're supposed to write 2 here, n, but you know when it's the square root, there's no need to write 2. So you have it to be what? Plus minus 2. Another example is 25 raised to the power of 1 over 2. It will be the square root of 25, which is plus minus 5. Now, if, and you can still have it, let's say 27 raised to the power of 1 over 3. This will be what? The cube roots of 27, which is what? 3. The cube root of 27, which is 3. Then the fifth law, which is a little similar to this, if you say a raised to the power of m over n, of course, this is going to be what? The n root raised to the power of what? M. So this is just like n power. So, and this can be synonymous to, for example, if you are given 27 raised to the power of 2 over 3. What this saying is going to be what? The cube root of into what? 2, which is 3 raised to the power of 2, which is 9. This is the fifth law. Now the sixth law. Now the sixth law is a little of equation. The law says that if you have a raised to the power of n is equals to a raised to the power of n. A little of equation. Base raised to the power of n is equals to the same base raised to the power of n. It says that therefore n is equals to what? N. What's the reason? You say same what? Base. If you have a raised to the power of m is equals to a raised to the power of n, it implies that n will be equal to n because the base is the same, therefore the powers will be the same. And the seventh one is similar to this. If you say a raised to the power of n is equals to b raised to the power of n. A raised to the power of n is equals to b raised to the power of n. That shows that since the power are the same, therefore the base implies that a is equals to b. What's the reason? You say same power. So please, in summary, this is indices. And in indices, we have the 7 laws, which I've explained. When you are multiplying, you add, when the bases are the same. When you are dividing, you subtract, the bases are the same. Now, when you have an indices whereby power into power, then it's going to be, you multiply the powers. Then you are going to see when the power is in fraction, then it's going to be the root of the denominator. When it is a fraction, it's going to be the root of the denominator. And I gave an example of this. And now what it is this again? It is m over n, which is the fifth law. It is also the denominator, the root of the denominator multiplied by the what? The numerator, which is n. Which is example. And the sixth one is a little of an expression of equality, where a is equals to a, but the powers are different. Therefore, those powers, they are equal. And when you come to a place whereby the powers are the same, but the base are different, then the base will be also what? Equal. Now please, this is simply about indices. And now we will be going back now to logarithm, to take logarithm and now get all the laws of logarithm again to express this. Now, this is the first class of indices. And in the second class now I'm going to take logarithm. And in the third class of indices and logarithm, now we are not going to deal with questions so that we will understand basically what indices and logarithm. Thank you.